Good morning, everybody. Good afternoon, good evening. Thank you for taking the time today to join our presentation. My name is AJ Durso. I'm the North American Business Development Manager for Consumer Electronics at Trinseo. I will give you a few brief slides kind of about Trinseo overview as a company, and then I will pass it off to our main presenter, Tony Samerkis. Today, we will be talking about plastics with recycled content for consumer electronics. The next, Tony. All right, a little bit about the history of Trinseo. We were originally part of Dow Chemical. We were their plastics division. In June of 2010, we carved out from Dow and became Styron. We were Styron until February of 2014, and we changed our name to Trinseo. In June of 2014, Trinseo IPO'd at the New York Stock Exchange and became a publicly traded company. Since the IPO, we've made one major acquisition, and it was of a company named Appy. Appy has a product portfolio that's expanded into soft touch TPEs and bioplastics. At Trinseo, we'll continue to go forward with our innovation. Some of our corporate facts. In 2017, we had $4.4 billion in net sales. We've got 16 manufacturing sites globally. Our three major business divisions would be performance materials, base plastics, and feedstocks. Currently employ around 2,200 employees. Now, with all of that covered, I will turn you over to our presenter, Tony Samerkis. Tony is the director of our technical service and development team in North America, along with being our global technology advisor for Trinseo's performance plastics business. He has 30 years of experience in the plastics industry. Aside from this 30 years experience and his technology innovation role, he's led a number of strategic global initiatives at Trinseo, one of which was the aforementioned acquisition of Appy into the Trinseo organization. Tony's located in Auburn Hills, Michigan. He works globally and holds both an engineering degree and a PhD in chemical engineering. And with all of that covered, it's my pleasure to turn you over to today's presenter, Tony Samerkis.
Thanks very much, AJ. Hello, everybody. So I want to give you a bit of a background before we jumped into our performance plastics business, just so you understand what we're about. Basically, our main focus is customers in a number of industries that are very focused on technology and performance, notably automotive, medical devices, consumer electronics, as well as lighting and electrical products. And the theme in all of these industries is figuring out where we can have technology-based product solutions that create value for our customers in those industries, but then also understanding how we can leverage them across industries where there may be recurring performance needs that we can meet with products over a range of industries. We have several products in our portfolio, both rigid thermoplastics and, as AJ said recently, thermoplastic elastomers. Starting with our caliber polycarbonate resins, our emerged advanced resins, which are PC or PC compounds and are particularly widely used in the consumer electronics industry. Our Magnum ABS products, which are used across a range of industries. Pulse is our brand of PC ABS grades for automotive interiors, as well as some consumer applications. And then we have our Enlight structural polymers, based upon a variety of different polymer compounds that are used in automotive, but also growing in other segments. And recently, with the acquisition of Appy, we have our Apilon, Megal, and Apigo soft touch materials, which are used again across a range of industries, and really bring a variety of attributes that really enhance the aesthetics and haptic and comfort aspects of our products. Focusing a little bit on the consumer electronics, this has really been an industry that we've been in for decades. You know, the joke is when a large screen TV was 41 inches and weighed 90 pounds, we were in the industry, and we're there today, obviously, with a very, very different products and participating in helping our customers, get down to the very small sizes that we deal with today. Our manufacturing footprint is global. Obviously, the focus now, because of where this industry largely resides, is in Greater China and Southeast Asia. but to ensure supply reliability and consistency, those products can be made all over the world, and they've been validated at our other manufacturing sites. The real focus, because of the increasingly stringent demands in this industry, is really high quality, high performance products with great aesthetics, and then all the quality management systems to ensure that we support our customers to stay compliant with regional and international quality and regulatory standards. And this is an area that we put a lot of product focus in terms of innovation and technical support, again, leveraging across industries as needed. And you'll see later that we've got a wide range of our Emerge flame retardant and non-flame retardant PC compounds with a tremendous range of colors. And that's an additional skill set that we bring to this industry, the ability to create high quality colors and deliver them consistently. The theme of the presentation, again, is recycle. And what we've been working on quite hard for the last 4 years and have commercialized over the last couple of years is our Emerge FR and non-FR PC polycarbonate eco lines, which contain large amounts of PCR, post-consumer recycle. And what's intriguing here is that we've managed to achieve virgin material quality in terms of aesthetics, physical properties, while maintaining, again, high levels of recycled content. And the additional key product, of course, for consumer electronics is our Magnum ABS resins, where because of their very low base color, allow for extremely rich, vibrant colors to be created at very cost-effective formulations. In addition, our TPEs now are growing in the consumer electronics area, both as accessories in consumer electronics, as well as for overmolding, where we also ensure a great match and compatibility between the TPE and our substrate materials to ensure robust performance. So that's a little bit of a background on Trinseo and consumer electronics. Now, the way this industry has evolved, as many of you know, I mean, traditionally and still to a large extent, it was based upon mobile devices, laptops, and increasingly tablets and so on. And what we're seeing is there's a bit of a merger or a convergence of consumer electronics as well as other industries. So you have the advent of smartwatches, which is a separate category, but that's now part of consumer electronics. There's the medical home care, home diagnostics, and in some cases even drug delivery. And those devices contain electrical features for in terms of sensors, communication, power supply. So that industry is embracing aspects of product performance that are needed for consumer electronics. And last but not least, in automotive, increasing amounts of consumer electronics in terms of informatics, and of course with autonomous and connected vehicles, consumer electronics is now finding its way into vehicles. So we're taking our consumer electronics technology and expertise and bringing it into these somewhat new segments. And a recurring theme in all of this is just a much greater emphasis and awareness of the whole question of sustainability. And sustainability basically means the avoidance of depletion of natural resources in order to maintain as strong an ecological balance as possible. But this is a recurring theme in this industry. So the rest of the talk will cover the following agenda topics. I'll talk a little bit as background of the different options for enhancing sustainability of plastics, some of the marketplace trends that are part of that. But I'll also talk about the challenges, particularly with post-consumer recycled resins, notably polycarbonate post-consumer recycled resins, but not only polycarbonate. There are cost challenges, there are availability challenges, quality and getting the right sorts of properties, which can be impacted by the type of PCR feedstock that you use. And then just show some examples of end-use products and targets for recycled product. And then I'll take you through our PCR polycarbonate portfolio, so you can see what we've achieved, and also share some of the challenges that we had. And we've overcome them. Some of them were tougher than others, but hopefully you'll find it instructive as you consider PCR compounds, either buying them or even developing your own. So let's talk about the need for greater sustainability in plastics, and a lot of this is well covered in the media, but I'll cover a few points. You know, the big drivers are fairly obvious to even a casual reader in the media. First, protecting increasingly scarce resources. Certainly reducing fossil fuel usage, as you guys all know, or you folks all know. Natural gas, or particularly petroleum, are the basis for our plastics. Reducing the usage of that can be a driver, as well actually as water usage as well. Secondly, the end-of-life question of plastics. Diverting them from landfills, which are increasingly scarce and expensive. There are issues of communities understandably not wanting landfills in their area. So again, protecting the environment by reducing the amount of material that goes to landfills is critical. And thirdly, I think there's just greater public awareness and education that you know, this is a subject that we need to take seriously and has long-term implications. So there's consumer demand for you know, proper stewardship and greater sustainability of our plastics. And of course, that also drives regulatory trends. So let's talk about the options for sustainable plastics. Three broad categories. Trinseo is involved in all of them for one or another of our product families. Bio-based plastics, and simply put, rather than using petroleum as the feedstock, we'd start with plant-based chemicals and feedstocks. And the idea here, of course, is that it's renewable, and you reduce the dependence upon petroleum, and also have more benign ecological footprint. Then you get into biodegradable plastics, and this ties into the end-of-life aspect and reducing demand for landfills. Again, here in a properly operating landfill, and that's a key point, biodegradable plastics will break down, will decompose over time back to their basic constituents, CO2, water, biomass, methane, and so on. But again, that works if you've got a properly constructed landfill. And third, and one of the ones that we'll obviously expand upon, is post-consumer recycle-containing plastics, which again allow you to avoid material going into the landfill. And also that ties into an area of increasing interest, starting in Europe, but it's happening in North America and elsewhere and different jurisdictions. The whole question of the circular economy, which is something that PCR plays to. If you think about the traditional, somewhat linear approach, on the left, you take raw materials, you polymerize them, you make a plastic, it's then used through the value chain and ultimately disposed of. And it may or may not get reused. You know, historically, and even to a large extent now, it's disposed of, and that's the end of it. And with the circular economy, as you probably know, the take, make, and use themes are still there, but then you have reclaiming the finished articles, recycling them in some appropriate way, and then reusing them at least as part of your feedstock system. And that, again, the circular economy is something that is upon us, and PCR is part of making sure that we're in sync with it and able to participate in it. And of course, government regulations continue to come forth that mandate some of the things I talked about in terms of PCR use or even elimination of plastics. We know that in California, a few years ago, regulations that prescribe certain amounts of PCR content in plastic packaging, and that has driven development of new grades of PCR-containing product. In Europe, there's been a ban on some single-use plastics that'll get implemented over the next few years. So really, it's incumbent upon all of us in the plastics industry to figure out how to comply with these laws and get ahead of them, and while still delivering value to our customers and ourselves. And in the consumer electronics world, the big players, as many of you know, are embracing this and have been for a few years. I won't go through every single bullet point. You'll get copies of these slides, but you know, Hewlett-Packard is being a leader and using lots of recycled plastic and using it in finished products. as is Sony, with specific targets for how much reduction of virgin plastic they aspire to achieve. And again, the key to managing it and making sure it's happening is measuring it and ensuring you're sticking to your goals. Dell has a pretty sizable goal and is on track for that. Philips, again, is very much involved. And last and certainly not least, Apple has been a real leader in the area of prescribing the use, ultimately, of bio-based feedstocks, but understanding that PCR has an important and valuable role to play on the path to bio-based. And they've announced that they're used in specific parts of the Mac Mini, in the MacBook Air. Apple announced possibly 3 years ago, I think 2 years ago, that they are using PCR plastic compounds in these internal speaker housings on mobile devices. So, this is, the industry has, including ourselves, of course, have developed the right grades. The customers are receptive, and this is moving forward. So it's no longer an option. This is a condition of participation in this exciting industry. Now, a point that comes up, and this particularly happened in automotive, because we did look at PCR in automotive, but also in consumer electronics, is, well, this is used plastic. PCR is used plastic, so it must be cheaper, right? And the answer is, it depends. It depends upon the end performance expectations of the finished compound that one has, the compound that contains PCR. So our learnings, and I'll take you through our journey, and our painfully won learnings, but they're institutionalized now in Trinseo, is that, if you want performance and aesthetics equivalent to virgin product, in fact, it's virtually impossible. It is impossible to make the products cheaper than virgin material. And that's a reality that needs to be understood as one gets into developing PCR grades. So what exactly are the performance targets you're looking at? If you want diminished aesthetics, or you can tolerate rather diminished aesthetics, reduced performance attributes in terms of physical properties and perhaps durability, then certainly it's possible to make PCR grades that are cheaper than PCR-containing grades that are cheaper than virgin products. But that's a particularly challenging task if one wants virgin-like properties. Let me talk a little bit about why that is. It's a bit of a build here. So the thing to keep in mind when developing a polymer compound that you want to have PCR content is, in that green box on the left, what are the finished product property needs? What are the performance attributes that your customer is going to insist upon, as well as having PCR content? And really, that's going to drive costs and the decisions and the selection that you make of the PCR feedstock and supplier. So, for example, what are the properties of the PCR grade you're going to buy in terms of color, flow, mechanical properties? Then the other factor is, who are you going to buy it from? How reliable are they, and can they produce the amount that you need? Because we did find we had missteps, 4 or 5 years ago when we got into this, where we just assumed we could buy as much of the PCR as we wanted at the quality we wanted, and that's not necessarily the case. So understanding that carefully is critical, and that's why collaboration as well between the innovation teams in your organization and your sourcing, your procurement teams are important. Then it's also a matter of understanding if your PCR supplier, your source, what are their internal quality controls and ability to comply with regulatory demands so that they can ensure you a PCR feed stream that will ensure that you're compliant with the various regulatory environments in terms of contaminants and REACH and other regulatory environments. And last but not least, what's the consistency of the product they can supply? And understanding all 4 of these factors are vital to developing PCR products that have the performance and cost structure that your business and your customers require and can accept. So let me elaborate on some of this now. So when you think about cost of PCR products versus virgin, I want to give you some perspective on several points that are different when you have a material, a compound that's got PCR content. And when I say different from when you have virgin materials, in this case, virgin polycarbonate. So it's the PCR feed stream is a raw material, but obviously with virgin products, you polymerize the product, the PC, and you have the customary controls for making polycarbonate. With PCR, you've got a whole supply chain or value chain of part collection, sorting of the parts, grinding them up, quality control. So somewhat more complicated from an operational perspective. Then from availability and shipment, it's pretty standard with virgin products. You have a plant, you make product, and you ship it. With PCR content, you can have these recycling plants located all over the place. Their proximity to recycling collection centers affects economics. So it gets more complicated and can be a factor in deciding who to source your PCR from. Now, the emerge grades that we have are compounds. They are polycarbonate based. They can have ABS in them, flame retardants, polyester, a variety of other components. And the formulations have been developed, and we continue to innovate in that realm. When you have PCR content, the formulations may become more complicated because you may need to innovate to compensate for any diminishment of product properties that using PCR could cause. So there's innovation that we learn has to be done to get virgin-like attributes. And the reality is PCR, regardless of how good a stream you get, is not going to be quite as clean, quite as uniform as virgin product. And one of the things that one learns, particularly as you get into production, is that you may have, depending upon the finished compound and its quality requirements, you may have an increased scrap rate, which also increases in cost. When the compounding happens, it's relatively straightforward with virgin products. Depending upon the compositions and the quality of PCR, your throughput can be somewhat lower. And as well, what we've learned is to assure virgin-like properties, there is more stringent quality monitoring, including more online quality monitoring so that we don't, nothing slips through and disappoints our customers. And then even in terms of normal quality control, the frequency is higher. What we found to assure virgin-like performance, greater frequency of controls are needed, and that's just a reality of it. Supply chain is pretty much the same. General overhead and other fixed costs, they're somewhat higher because, again, you've got these quality controls in place, incoming material screening, and so on. So the point I'm trying to convey here is there are a number of substantive things that need to be done that do add cost if you want to make virgin-like finished products with PCR content. And note, these points are the case not only with polycarbonate compounds, but if you want to use other types of PCR sources. And they're critical to keep in mind as you decide what exactly you're trying to achieve, what sort of properties do you need, and what sort of cost structure can you tolerate in the finished product or that your customers can tolerate. Let's get a bit more specific to kind of take you through some of our journey on developing PCR polycarbonate products. And really, we had a pretty steep learning curve to understand all the different types of PCR that could be available. And we knew we wanted, again, great aesthetics, so we wanted material that was pretty clean. So we found that you can deal with recyclers that start with safety glasses, headlamps, clear PC film and sheets, even DVDs. And those can be ground up and taken through a wash process, compounding process, and you can get what we call in the upper right there an A grade or an A+ grade, very high quality PCR. And in fact, the A+ grade is what we typically use, as well as the A grade. And you can see some of the emerge grades that are mentioned on the right that we create with PCR products. You can also go to lower quality and start with water bottles where you've got tinting, and that controls the finished color. And you can also get an A grade with a different color though, and we also do use that. And lastly, if you get into real, cats and dogs miscellaneous articles, you get a grade, what we call the B grade, that much grayer in color and just not as consistent. And that we've learned painfully several years ago that you can't use that product. And I say painfully only in the laboratory, not out in the marketplace. So we've really gravitated towards the higher performance, higher quality PCR grades, and are working with really outstanding recyclers to assure that. And as you can see here, these are being provided to our plant in Trinseo in Taiwan. Let's get a bit more specific now. Now, a key thing to keep in mind as you embark upon looking at PCRs is understanding, are the grades of PCR that you're going to use going to be compliant with the different regulatory standards that you have to live with or that your customers have to live with. And what our product stewardship organization in Trinseo is exceptionally strong, and with team members in Asia and Europe and in the US, and they've been very involved in this. So, you know, we've confirmed that in terms of row house and REACH compliant, which are initially driven, well, row house initially driven out of Europe, REACH is purely European. We can meet those requirements with our A+, our A grade, and our B grade. And we've had that validated at external laboratories. Substance is a very high concern, SVHC out of Europe. Again, the A grades and the A+ grade can meet those. The B grades, well, we can't be sure that they can. And our suppliers have been really good partners. They said, look, we're not going to commit to you that we can do that. So we've stayed away from those products. And then in California, we've for the packaging requirements, we've confirmed that in fact all three grades can help ensure that we get above 25% PCR content, as well as for EPEAT out of California. Now, the other point to consider is, what are the aesthetics? What are the colors of the final compound you're going to make? And what we've learned, if you want vibrant, bright colors, white colors, light colors, only the highest grade, what we call our A+ grade, will give virgin-like, actually not virgin-like, virgin equivalent aesthetics. However, if you get into black parts, you've got more flexibility, and you can use any one of the grades from a color perspective. But you know, the message here, because of particularly the regulatory requirements on SVHC, we only use the A+ and the A grades with one or another tint. But again, you know, understanding these regulatory aspects are vital, so you don't have a situation where your customers or yourselves, if you're a purchaser of PCR compounds, you don't get into a regulatory situation. So we really went deeply into this and feel good about our ability to comply and ensure no surprises for anyone. Let's talk about some of the properties of our virgin PC, a typical 15 melt flow that we polymerize, and then looking at a couple of our PCR suppliers. And really the focus here is, you know, transparency, give us a feel for how clean the material is, and then mechanical properties and flow, the tensile at break, tensile strength at break, at yield, and then our modulus. And we feel really good that we've found sources, and this is our A+ grade, that are equivalent to our virgin product and can be used in our formulation successfully. And gratifying that our customers have validated it and are now buying these products, including the white ones, after we've proven that we can robustly, reliably provide the same performance. But the key is getting a great grade of PCR, making sure you got a robust supply chain, and then formulating with it, because inevitably they do have some diminishment of properties because of their extra thermomechanical history. So, you know, a key thing to keep in mind before you get into this is, you know, where can you think about PCR and where shouldn't you think about it? And, you know, what we learned, because, you know, we got a pretty strong presence in the medical industry with Fortune 50 companies, PCR for medical is really a non-starter. You know, that industry is just not receptive because they've got so many regulatory requirements from a health and safety perspective, you know, constant skin contact, et cetera. They're really not into the area. Automotive is open to PCR, and we do work in this area, but it's a different mindset. It's very much willing to accept a diminishment of some properties, and understandably then they expect a lower price. and the applications are typically non-show applications, so the aesthetics are not as critical. Applications where that are not safety critical, so they're not involved with impact, like knee bolsters or pillar trim where an airbag may deploy at low temperature. But again, automotive is open to PCR, but typically is looking by necessity for some cost benefits and are willing to give up performance. And really, again, as I said, in consumer electronics, that's probably, in our world, in our business, that's the area where we've put the most effort and had the most technical success and success. Our customers have been successful with them as well, because there they've really focused on equivalent performance and have been able to tolerate some modest cost premium. So with that, let me talk about specifically what we've achieved, the sort of product portfolio that we have, and this is reflected in our Emerge Eco grades. Now these are, as I mentioned earlier, PC and PC ABS compounds that are either FR, non-FR, as well as glass filled. We'll talk about what we've done there. A really critical thing is, before I show you the portfolio, is to also understand what's your formulating space. How much PCR can you use? And the answer is it depends on the properties you want to achieve. So on the left, you can see an example of transparency. So this is for a clear material as a function of PCR content. So 0% PCR is virgin material, but also as a function of thickness. So you can see that, starting at a fairly thin part, 1.7 millimeter, we're up in the, nearly 90% transparency. And as you put in PCR, that diminishes. So, it's important to understand what you can achieve and what you can't achieve. And this is with our A+ material. And of course, as you go to a thicker part, you get a diminishment of transparency. But this gives us a feel for our design space for PCR in transparent materials. And then if you think about a white product, the question becomes, and this is where our commercial teams challenge us, well, depending upon the melt flow, how much PCR can I put in and still get, the necessary white, white performance? And the circles in within that shaded area are products that we have that are commercial, and the upper and lower lines represent the boundaries of what we can formulate within in terms of PCR content, melt flow, while maintaining, the necessary whiteness of our products. And the same applies for our black products. Now here we can do this as well with our A material. We don't need just our A+ to achieve this, but you can see our formulating space. So we can also be very, realistic and candid with our customers when they're asking for new grades. But we do have a pretty wide formulating window, which is pretty gratifying and reflects the quality of the PCR that we use, as well as our innovation to achieve virgin equivalent properties. This is an example. I'm going to show you the breadth of the portfolio, but this is an example of two key products that we have: the Emerge 8600 E for Eco 50s, that's 50% PCR content, and then our Emerge 4330 PC, that's non-FR, and it's got 75% PCR content. And you can see a photo on the left of the whiteness of the pellets. You can see the color numbers, the equivalency of the virgin and the PCR material. They're really overlays. And really the key attributes that we've achieved is just extremely clean material, without any more black specks than our virgin product, and those are virtually non-existent. Pretty large carbon footprint reduction, and I'll talk a little bit about that in a couple of slides, and achieved V1 at 1 millimeter, V0 1.5 millimeter, and then RTI, which is critical, at 125 Celsius. So very robust performance. We've also gotten our PCR content and the way we operate our plant validated by UL according to their environmental claim validation protocol, ECVP. And again, this is reflected in again our UL card. So we didn't try to do this as a let's put in PCR to take out costs and let's not talk about it. Let's make it really robust and do the sweating and the heavy lift to get all these validations, so that then when our customers buy these products, they're not going to be surprised by, let's say, what if we're not actually using as much PCR as we say? Now here we validated and confirmed it through our UL certifications, which we maintain. And this is a bit of an eye chart, but that's okay. You'll get a copy of it. This is our PCR polycarbonate containing product portfolio. So this is our Emerge family with PCR content. And we start with transparent products. Our 84-10, which is 50% PCR content, down to V0 at 1.8, as well as a near-infrared transparent black. And you can see the PCR contents are quite high. If you're dealing with non-FR, we're up over 60%, in a number of cases 75%, whereas we go to 50% for the FR grades. And then for the opaque grades, you can see we go down to V0 1 millimeter for our 8160 eco grade. And again, we cover a range of melt flows. And again, there we get into our PCABS grades, the 7560, 7590 with a 60% PCR content. And again, a little bit lower, 55% if there's Arctic white, but again, quite robust, and again, with all the necessary UL certifications. And then we get into our high heat distortion temperature grades, which are glass filled, again, with very high levels of PCR. These are all proven out with the formulations optimized to get the properties that we need, and the manufacturing controls in place to guarantee the quality that's vital to our customers. So pretty broad portfolio, and this will continue to grow as we customize for different customers' needs. And again, here's an example of our certifications with regards to the UL claims on ECVP. So again, these are our certifications. So if there's a situation where your customers demand this certification, we have it in place and maintain it. We take that quite seriously because it's good for just ensuring the quality of the product and being able to allow you to convey that to your customers. Now, let's circle back to some data on sustainability, because that's what this was all about. One of the things that we did is we also had a third party do life cycle analysis, LCA, from cradle. It used to be cradle to grave, but now it's, I've been coached that it's cradle to gate. I think that sounds less onerous. And what we actually did was, for several of our grades, and they're mentioned here in each of these slides, have this outside party do the life cycle analysis to understand first, in the upper left, the amount of CO2, kilogram equivalents per kilogram of the finished compound. What is that CO2 generation, or in the course of making it, as you add PCR versus the virgin product? So if you look at the upper blue line, let's say for our 8600 eco, for the virgin grade, the 0% PCR, it's roughly 5.1 kilograms of CO2 per kilogram of the finished compound. But when you go to 50% PCR, that 5.1 comes down to about 3.2 kilograms of CO2 per kilogram of compound. And you can see we've had this done for 3 of our products. Again, in the left 2 graphs and the upper right one, you can see the amount of CO2 generated. On the lower left, the amount of energy used in megajoules to create the product. And the graph in red is for a PCABS grade. And again, the amount of energy is lower because, again, there's ABS in there as well as PC. Also, we look at water consumption. So this is fresh water, and water usage is also diminished by increasing the amount of PCR. Again, we have that documented. And then we also have the CO2 kilograms of equivalent for our glass fill grades. And we did this as a function of glass level. And you can see for a 30% product, the 4903, that fits right there in the middle of the graph. So these are the sorts of data that we can share with our customers. So again, when you want to make the case to your customers, we have objective third-party data rather than just opinions and hand waving. So to summarize, we've had an interesting and actually pretty fun and gratifying journey in the PCR world, PCR-PC world for consumer electronics the last several years. And really, the key that we learned, and we stubbed our toe a couple of times at the beginning, but is to really understand what are the technical demands of the finished compound. What are the regulatory constraints that you and your customers need to live within? Because answering those two questions will help hone you in on what sort of PCR grades you need, and to some extent, what sort of innovation you may need to do in terms of developing the PCR grade. And we've gone through that, and that's why we've got such robust grades, because we went through these points and now have our portfolio. We've established a number of very reputable PCR suppliers who understand our focus on quality, consistency, reliability of supply. And based upon that, we've got really robust products that have the right PCR in them to assure, again, the quality and performance that our customers need. And, a great partnership that we've had with our procurement organization to really, vet these PCR suppliers, vet their credibility, their compliance with regulatory rules, so that our products then can be assured to comply with the various regulatory regimes that our customers are in. And of course, we went through a lot of sweating, a lot of brain work to innovate these grades, to mitigate any of the diminishment in properties that occurs with PCR, as well as enhance our manufacturing controls to ensure that our customers get virgin properties from these PCR compounds. And really, we then went the final step to make sure that we had data in terms of LCA, so that we could objectively show that and quantify sustainability improvements with our products. So then we could, assure our customers that they were working towards their goals, and then allowing them to successfully promote their products containing our PCR grades. And that is all. So thank you for your attention. You'll all receive a copy of this webinar, and it'll be available online. And then if you have additional questions about our portfolio of PCR emerged grades, I encourage you to reach out to Jane and AJ, both located in California, but they work all sorts of crazy hours, so it's not an issue. And they can, meet your needs with our products, and if the current ones don't meet your needs, we'll happy to look at developing new PCR grades that do meet them. And looking forward to any questions that you may have. Okay. One question that came up is, do we do anything with PIR, post-industrial recycle, polycarbonate or other plastics? And the answer is yes, sometimes. So PIR is material that may be scrap from our plants, and we do use it in some applications, but the same care has to be taken depending upon the end application. Some end applications of our compounds, where you need very high aesthetics, even PIR is not acceptable. So we do it selectively. The other thing to keep in mind is that to stay compliant with various regulatory regimes, like the California one on packaging and recycled content, or to stay compliant with some companies' internal targets, PIR is not acceptable. They do require PCR. The other risk with PIR is that there's sometimes it can be more variable, and you need to be at least equally selective with it. So that's want to address that point. Any other questions? I'll take a look over here. Okay, so I have one, what kind of applications do you see with PCR-containing materials? So we've seen them in really all the customer applications of our emerged grades, whether it be power adapters, housings, various small components in consumer electronic devices. So really, the applications are all pretty much the same as with our virgin materials, because again, we have virgin-like properties. Okay. Okay, so one person said, I have an application to incorporate 40% PCR into a product that has both transparent and opaque parts. How would I tackle that? Okay, that's a good point. So the thing to keep in mind then is if your overall target is 40%, you'll have to look at your particular system and say, or look at our particular system, ideally, and you might find that you'll have less PCR in the transparent part of the product, and then more PCR in the opaque. So you have to look at the overall target, and then make selections from our portfolio depending upon what can be achieved on the clear part, the transparent, and on the opaque. Okay, any additional questions? Okay, well, if there are none, thank you for your attention and time, and I hope you found this instructive. And as I said, you'll get copies of the presentation afterwards.
All right, Tony, thank you so much. That was a really great and informative presentation. Like Tony was saying, we will be sending you guys a copy of the presentation and the slides to you via email, so do be checking your email for that in the coming days. We'd also like to encourage you to check out some of the other great Trinseo webinars that we do have on the Prospector Knowledge Center. Wanted again to thank our audience for attending, and have a great rest of the day.